Hi, everyone, and welcome to MiceTech Talk with the Technical Information Scientists of the Jackson Laboratory. My name is Dr. Janine, and I'm coming to you from my home office in Sacramento, California.
Hi, and my name is Dr. Doloress. I come to you from also my house in Sacramento, California.
Our job as technical information scientists is to serve the research community by answering all of your mouse-related research questions. You might recognize us from our formal webinars that we usually have on Thursdays, or you may have called or emailed us at micetech@jax.org asking for help.
MiceTech Talk is a weekly 15-minute podcast-style webinar where we answer frequently asked questions regarding mouse research.
All right, so hopefully you've gotten your coffee and you've put your feet up because it's time for MiceTech Talk. So today, let's talk guidelines for a well-written manuscript.
Great. So the motivation for this talk was to help our fellow researchers prepare for not only submitting grants, but especially to get their work published, as well as bringing awareness to the 2019 guidelines for animal research, reporting of in vivo experiments, which is a great resource that points to key information to include so that your peers not only can look at your work, evaluate it, but most of all, they can reproduce it if needed and build upon it, which is a very interesting way that science moves forward.
Great. So we have two poll questions today. I'm going to open the first one, and you'll see that open on the right-hand side of your screen. Go ahead and select the appropriate answers and then click submit so we can see them. And there's a visual component to this one, which is the cutest mouse? Go ahead and answer. You can choose as many options as you'd like. And Doloress, you can vote too, I think.
Okay.
And you're going to just do A, B, C, or D, and then remember to hit submit. All right, I'm going to close the poll. And I'll show you guys the results right now. So everybody liked Mouse D, Doloress, which I think was the little black and white one. So
yeah, it was my favorite too.
You guys are right. That is the cutest one. Okay, I'm going to open up poll question number 2. So this one's related to our content, and this one is a little bit more specific. So in publications that you've read, or maybe publications that you've written, what details do authors fail to communicate about their mice? Is it A, strain, substrain, and catalog number of the mouse they used? B, number of mice allocated to each experimental group? C, is it sex of the mice? D, age of the mice? E, housing and husbandry conditions? Or F, experimental procedures in enough detail to allow others to replicate them? There's no right or wrong answer. It's just what have you experienced? All right, I'll give you guys a few more moments for that one. And I'm going to close the poll and show you guys.
We should have put all of the above because really, in my experience, it's all of the above.
Yeah, it was select as many as you want. So you could collect all of them if you want. So it looks like we've got overall pretty even distribution. It looks like F is the slight winner of experimental procedures in enough detail. But things like strain and substrain, people have missed out on. The N, the number of mice. We see sex and age, husbandry and housing conditions. So pretty even spread. So what would you say about that, Doloress, those results?
Yeah, it's like I said, I feel like a lot of times it's all of the above. You really do need to have all of that information in order to understand if the experimental design was a robust one. And also, I mean, do you have all of the information if you were to reproduce this in your lab? Without this information, it's really hard to do.
Yeah. So we have a few discussion topics based on the ARRIVE guidelines. Just to note, you guys have a Q&A section there, so you can ask any content-related questions or make any comments throughout the presentation. And Dr. Doloress and I will try to read and answer them or comment on them as we see. So Dr. Doloress, you are now sharing with us the ARRIVE guidelines. Why don't you give us a quick overview of what they are and why were they developed?
Absolutely, absolutely. So this was developed by a group in the UK approximately 10 years ago, back in 2010. And the idea initially was came out of frustration. At the time, they had commissioned sort of a survey looking at a little bit less than 300 papers and see what kinds of information were reported there. And they saw that the vast majority of them just did not have relevant information. In case people were thinking about doing a study, there was not enough information to see was a study done already or not, and so on. So at the time, unfortunately, the guidelines that were developed did not really stick too much with the research community. And so people didn't adhere very well to them. And these guidelines were recently updated in 2019. That's a paper that I'm showing on the screen. And the information was reorganized. And also, as you can see here, as far as the authors, it's beyond the UK. There's a lot of groups, including very strong journals like Nature, for example, from the US and other countries as well. And the nice thing about it is they have reorganized the critical information that needs to be on a paper, whether you're writing it or if you're reviewing it. A lot of us have reviewed papers, and that's part of what we do. And so it's a much easier way to structure the information that is needed. And as you can see here, I'm just going to scroll quickly. There's the 10 essential items that need to be there. And then there's a set of recommended pieces of information. And it's nice because it's organized per section of the paper. So Dr. Janine, I'm going to go back to the 10 essential guidelines here. Do you want to comment on perhaps some of those? We don't have time here to go over absolutely everything.
Sure. Yeah. So there's things, if you're just listening, it's just study design, sample size, inclusion and exclusion criteria, randomization, blinding, outcome measures, statistical methods, experimental animals, experimental procedures, and results. So I think I like this because it's a very checklist kind of format, and I like checklists. I went fishing this weekend, and I had a checklist of all the things I needed to do before going in the morning. So I think if I had known about this guideline before I had written any of my papers, it would have given me a lot more detail to draw upon, and so I didn't forget things. So I will go into some examples shortly, but I would say like study design, sample size, randomization, blinding, and statistical methods. We actually are probably going to talk about a little bit in one of our upcoming MiceTech talks, but we also have an entire webinar about experimental design that you guys can refer to as well. So for this one, I wanted to point out number 3, which was inclusion and exclusion criteria. Any kind of criteria for why you might remove an animal from a study. I think sometimes we're researchers want to remove kind of what they call outliers because they are very different from the rest of their data. But we have to remember that mice are biological entities, and so an outlier might just be the natural biological variation from one mouse to another. Something that you could definitely exclude from your studies would probably be a mouse that's very ill. So I remember having a mouse that had a very enlarged spleen, and I probably should have talked to my veterinary group there about why this mouse had a very large spleen. And that definitely would have been a good reason to eliminate that mouse from the study because it was sick.
Right. The key word, if I can add, Janine, here, the key word is a priori, meaning you need to establish this criteria before you start the study, not because, as you said, you have an outlier dot in your graph and then it doesn't fit with your story, and then at that point you're going to remove it. That's not right.
Yeah, absolutely. The other point that I'll go to is probably 8 and 9, because those are kind of the two like mouse-related ones that we can really point to. So number 8 is the experimental animals, which we alluded to in our poll question, so I won't go into further details about that. But experimental procedures, one that kind of surprised me was the acclimation period in part C that you're highlighting now. That was something I also didn't realize that was really important, that mice are coming from a facility and then coming to your facility, and that that process of coming to your facility is actually very stressful for mice because they have they like kind of things to be the same around them. And so being put into a different box and then shipped across country and then unloaded to different food and different bedding, different water, different humidity, different light cycles, that all can actually affect your experiments and the mice themselves.
Absolutely. Absolutely.
So yeah, should we look at some of the ARRIVE guidelines in action?
I think that's a great idea. I think that's a great idea. So this is a paper. We were trying to find like a good example of a paper that applied the ARRIVE guidelines, and a not too good example that we're going to start with a paper that did not consider a lot of these guidelines. And Janine, you graciously volunteered one of your papers. Do you want to talk about it a little bit?
Sure. So I, in graduate school, studied a protein called TWIST, which is a transcription factor involved in breast cancer metastasis. And one of the things I looked at was the contribution of CCL2 and how it contributed to macrophage recruitment and angiogenesis development, which is an important factor of cancer spreading and metastasizing to different organs. So I said, why don't we look at my paper? I didn't know about this checklist. How well did we do? So, or how well did I do? So out of 10, I gave myself kind of a generous 5. These are not, really strict guidelines, but I kind of estimated that I definitely have room to grow and room to improve. So I used mice. I also used chickens for an angiogenesis experiment or assay. And I used mice in 2 sections. I don't actually have a section that talks about the chickens or the mice in here, but they're kind of integrated into different parts of the materials and methods. So I allude to some of the mice in the cell lines and cell culture section where I talked about primary bone marrow derived macrophages. And then I referenced another paper. That particular paper used C57 black 6 mice. I didn't talk about the sex of the mice. I honestly don't remember what we used. It might have just been whatever mice that were available to harvest from at the time. I don't know the age of those mice. I also don't know if any of this even matters for my particular study. But I think that's an important, an example where I didn't realize that this might be important, and that could be a reason why certain things don't work. The other place that I looked was in the I think it's lower down on the matrigel section.
Yep, here you go.
Yep. So you can see this one. I used adult BALB-C mice. I didn't actually put the substrain there. I don't actually know where we got them from because that was something that my lab manager had ordered. And so I didn't know. I knew that I needed BALB-C mice because I was using BALB-C cell lines. But I just said that they were adult. I didn't say that they were female. It was kind of implied because it was a breast cancer study. So I definitely found a lot of places where I could have done better. And for myself, for number 8, under experimental animals, I gave myself a 0 because there were a lot of things that I left out. And I think I'm probably very hard on myself now, especially about this part because it's the mouse part of it, right? And that's what I do now for a living. The other thing that I didn't do well, I didn't talk about blinding and randomization, even though I did those, practice those, but there are a lot of things that I just left out because I didn't realize they were important for the study.
Right. All right. Shall we move on to the other example?
Yeah. Let's see your other example.
Well, thank you so much for showcasing one of your first papers. Thank you so much for that. So this paper ranked pretty good as far as the 10 essentials and the recommended lines. And I'm going to just jump straight to the method section. So from what I could tell, they included everything from the 10 essentials, except for they did not mention anything about blinding and the criteria for inclusion and exclusion. Perhaps they had one, perhaps they blinded themselves, but they were not communicating that. But the rest is amazing. I mean, as far as animals and reagents, they tell you not only the strain, the substrain, the catalog number, all the way to the housing conditions, the catalog numbers of the diets that they were giving, as far as a bunch of other catalog numbers of all the reagents that they used. So this is a very nice example of if somebody wanted to do this again or part of it, build upon this study and go further in the questions that they ask with these kinds of models, this is something that people could reproduce a lot easier. So that's why I picked that particular, this particular brain. And then the study design is so well explained. I really like that. So if you wanted, like I said, to either, you can tell that it was carefully designed, which is nice, and it allows you to repeat it if needed. So I know that we are have just a few more minutes left on the clock here.
Yeah.
Shall we go to one of the questions?
Yeah, I see one here. Someone's asking, what are the options if the paper doesn't list enough information to figure out what mice or mouse strain that they used? Dolores, do you want to try and tackle that question?
Sure. So basically, if I understood correctly, if you read a paper and there's not enough information about what the mouse is, what type of mouse, yeah. Well, I mean, there's always a corresponding author. My first reaction would be to just email the corresponding authors. Typically, they love to respond about the work. Another thing that you can do is contact MiceTech@jax.org. We do a lot of detective work behind the scenes, even if it's not a JAX strain. We do use MGI and other databases to track down what may be the formal name of the mouse in a paper and try to track down which repository has it, not only JAX, but maybe somewhere else. And we can see if those mice are available for sale somewhere in the world, or the only way you can get them is if contacting the researcher directly. So we are a great resource for that kind of behind the scenes detective work.
Yeah, I'll just add sometimes it's just helpful to talk to someone else who focuses on mice so frequently that we can quickly see, oh yeah, that wasn't enough information to determine which mouse strain that is. Or we might be able to say, oh, that's, it might be this one, but I'm not really sure. And the consequences of that could be that there are differences in substrains. There's differences in how different mouse models are created. So they might call it a particular knockout, but there might actually be 4 different knockouts that exist in the world. So I think there's definitely room for improvement in the research community to be more specific about the nomenclature. And that's also something that we can help guide you on, is figuring out what the appropriate nomenclature is for the strains that you're using.
Another thing to add to that, Janine, is that sometimes, even if there are different versions of let's say, knockout of gene A, there's, maybe 10 different versions in the world of knockout of gene A, but a lot of times it's one specific knockout, but the phenotype can be different if it's in a different genetic background. So that is also something that people need to keep in mind. And again, don't hesitate in contact MiceTech@jax.org for that kind of help. We are super happy to help researchers with that.
Yeah, I think one of the challenges is, A, you don't realize it's important, and B, sometimes there were, at least in my time, there were space limitations for how much detail you could put in the method section.
Absolutely.
But it sounds like, especially, Nature and PLOS are definitely trying to address that, because there's so much room in supplemental figures.
Absolutely.
We've got such a digital community that now there really isn't an excuse not to include that information.
Yeah.
All right, well, I think that's all the time we have for today. Our next MiceTech talk is called Let's Talk Humanized Mice Part 1, which is actually going to be on July 14th. So we're skipping next week and having a little vacation. We're also going to be moving to a new platform that's hopefully easier for you to use and will not involve any kind of registration process. All you have to do is follow the Jackson Laboratory on LinkedIn, and you'll get a notification on your phone when we go live. You can also attend live on the Jackson Laboratory's YouTube channel, which is where we're going to post all of our old episodes on a playlist, but you can also sit in there and comment, and we'll be able to comment with you back and forth on there too. So hopefully we'll see you guys there. This is Dr. Janine saying we miss you, and we are looking forward to seeing you on July 14th on LinkedIn and YouTube. Stay healthy, stay safe, and stay excited about research.
Bye, everybody.
See you guys.